Hello again. In our last video, we learned how to write the equation of a line when we know the slope and the y-intercept. We used y equals mx plus b. Now we're going to answer a different question. What if we know the slope of a line and one point on the line, but we do not know the y-intercept? In that case, point slope form is very useful. Here is point slope form. This is point slope form. Y minus y1 equals m parentheses x minus x1, where m is the slope and x1, y1 is a known point on the line. Okay. Here I have written example number 1, and we're going to look at this together. It says write equation of a line with a slope of 3 and it passes through this point here. So notice we don't know what this equation looks like, but we're going to solve for it. So the slope is 3 and it passes through 2, 5. So we're going to start with the point slope form. We're going to start with y minus y1 equals m parentheses x minus x1. Now we're going to substitute. We know the slope is 3. So I'm going to substitute the slope in there. And I also know that we do have a point. We have x1, y1. So x1 and y1 can be substituted as well. y1 is 5, so we're going to have y minus 5 here equals 3 parentheses x minus 2 there. So y minus 5 equals 3 parentheses x minus 2. This is already a correct equation of the line. If we want the slope-intercept form, we can simplify this. How do we simplify? Very easily. First of all, we want to use the distributive property. Y minus 5 equals, I'm going to distribute the 3 here and the 3 there over multiplication. So 3 times x, 3x, 3 times a negative 2 is going to give me a negative 6. Then from there, we're going to add both sides, or add 5 to both sides. This cancels out. We have y equals 3x minus 1. Therefore, the equation can be written as y minus 5 equals 3 parentheses x minus 2, or y equals 3x minus 1. Both of them are correct. Let's continue. Example number 2, negative coordinates. Write equations of a line with slope m equals negative 2 passing through negative 3, 4. So we're going to use the point slope formula again. We have y minus y1 equals m parentheses x minus x1. I'm just going to label my points. So we have y minus 4 equals negative 2 parentheses x plus 3. Okay. Notice it was already subtraction, so a double negative is the reason why I made this a positive here. Okay. So be careful here because subtracting a negative becomes addition. Let's continue. So if I were to continue to compute this, we would do what we did last time using the distributive property. Negative 2 times x would be negative 2x. Negative 2 times 3 would be negative 6. Adding 4 to both sides. we end up with y equals negative 2x minus 2. Therefore, this is our final equation. One common error is a student is given the point negative 3, 4, and they write y minus 4 equals negative 2 parentheses x minus 3. Are they correct or are they incorrect? The x coordinate is negative 3, and the y coordinate is 4. So notice if that if this is a negative 3, they should have wrote negative 2 parentheses x minus negative 3, and then that would have generated the appropriate response, which was to compute it as follows: negative 2 x plus 3. That is what the equation should have been. So again, this is valid, or you can compute it even further to simplify the equation into point slope form. Let's continue. Example number 3, fractional slopes. Write equation of a line with a slope of m equals 1/2 or 1/2 passing through 4, negative 3. Using point slope formula again, y minus y1 equals mx, in parentheses, x minus x1. I'm just going to label these points x1, y1, which is going to be y plus 3. And notice I went ahead and did this, but again, you need to be careful and know that it's going to become a positive there. Equals 1/2 parentheses x minus 4. Continuing on, we can use the distributive property. Y plus 3 equals 1/2 x. 1/2 times a negative 4 is going to generate a negative 2. We can subtract 3 to both sides. Subtracting 3 to both sides, we end up with y equals 1/2 x minus 5. Example number 4. Suppose we claim that the equation of the line through 2, 7 with a slope of 3 is y equals 3x plus 1. Let's verify that. First of all, check the slope. The slope is 3, so that matches. Now check the point. We're going to substitute x equals 2 and write y equals parentheses, or 3 parentheses 2 plus 1. Y equals 6 plus 1. Y equals 7. So the point 2, 7 does satisfy this equation. So notice when you're given a point and the claim is that this point is on this particular graph, you can verify it by substituting one of the points into the equation and computing it as follows. Let's continue. Now I want you to pause and try this. The question says, write the equation of a line with a slope m equals negative 3/4 passing through 8, 2. Write your answer in slope-intercept form. So the first thing you want to do is I want to start with y minus y1 equals m parentheses x minus x1. I'm going to substitute the information that I know about this problem, which is m is negative 3/4. And then we also have x1, y1. So y minus 2 equals -3/4 parentheses x minus 8. Simplifying this, we have y minus 2, -3/4 x. Now, when you're multiplying fractions times this, um, you, depending upon your level of skill, come over here and do -3/4 times -8/1. 3, and you know the rule is with fractions, you multiply the numerators together, multiply the denominators, or multiply straight across. So a negative times a negative is going to give you a positive. This is going to be 24/4, which generates to 6. So plus 6. Now, we need to add 2 to both sides. Adding 2 to both sides. The final result is y equals -3/4 x plus 8. And that is our final answer. The next example is example 5. Consider the line with slope m equals 2 passing through 1, 3 using the point slope form. So the slope is m equals 2 and it passes through 1, 3. So we need to use point slope form. So I'm going to write y minus 3, which is the slope, or excuse me, which is the point here, y minus 3 equals the slope of 2 parentheses x minus 1. Using the distributive property, we have 2x minus 2, adding 3 to both sides. We have y equals 2x plus 1. So again, using point slope form, we can write it as such, and we can leave it like this. We don't necessarily have to go any further. You can leave it. Like this. But I chose to show you both in the event that you come across a problem like this. Now, the next thing I want to look at is all right, the last video ended accidentally. So what I want to do is we were working on example number 5. Consider the line with slope m equals 2 passing through 1, 3 using point slope form. So again, y minus 3, which is the slope, equals 2 parentheses x minus 1. And then I just computed it and brought it to the point slope form. Now, again, you don't necessarily have to do that because it just says using point slope form. So consider the line passing through that using point slope form. So we pretty much did that here. But what I want to show you is that what if you were given a different value? Suppose if we were given, let's say 4, 9, which is x1, y1. Well, we would treat it the same way. We would do y minus 9 equals 2 parentheses x minus 4. Y minus 9 equals 2x using the distributive property, 2 times x, and then 2 times -4, which is going to give me -8. Adding 9 to both sides, then we're left with y on the left-hand side equals 2x plus 1. So these two are essentially, or this particular point, we could say is also another point on the same line. 4, 9 is another point that is on that line as well. So these look different, but they're really they're really not. Okay. So even though you have 2 points that um that essentially we were trying to consider whether or not they were on they could help us find out what the function means, they ended up yielding the exact same function. So both equations simplify to the same line. And so this shows us that any point on the line can be used in point slope form. The reasoning question today is write a line that passes through 2, 5 with a slope of 3. Student A writes y minus 5 equals 3 parentheses x minus 2. Student B writes y equals 3x minus 1. Are they both correct? The answer is yes. Student A uses point slope form here. Student B simply simplified into slope intercept form, and they're both correct. Let's just verify that. So we have y equals 5 equals 3x minus 2. I'm going to distribute first. 3 times x is 3x. 3 times negative 2 is negative 6. Add 5 to the left. Add 5 to the right. Y equals 3x minus 1. So notice this checks out. They're both correct. One chose to use leave it in point slope form. The other chose to simplify it into slope intercept form. So the equations are equivalent. They describe the exact same line. Example number 6. A company charges a delivery fee that increases at a constant rate. When delivery distance is 4 miles, the cost is a flat rate of $11. The cost increases by $1.50 per mile after every other mile. Write an equation line for the total cost. So the slope is the rate of change. The slope is m equals 150. And we also know the point. The point is 411. Let's use the point slope form. So we have y minus 11 equals 150 x minus 4. Now again, you can leave it like this or you can simplify it, which in this case we have to because it says write the equation for the total cost. So computing this, we have y minus 11. 150 times x is just 150x. 150 times a negative 4 is negative 6. We're going to add 11 to both sides. The final equation is y equals 150 x plus 5. Now, what does this mean exactly? We have to interpret the equation. The slope is $1.50. So that means that the cost increases by $1.50 for each additional mile. And the y-intercept of 5 represents the base delivery fee before mileage is added. And so this is an important level of reasoning because we are not just writing an equation, we are interpreting what each part means. So just to sum up this video, the point slope form we discussed was y minus y1 equals m parentheses x minus x1. So you have to remember to use the point slope form when you know. 1 point and the slope. Always use the point slope form when you know 1 point and the slope. And be careful with substitution, especially when coordinates are negative. Then simplify only if the problem requires a different form. In the next video, we'll learn how to write the equation of a line when we are given 2 points. Again, thank you for watching.